Hi, my name is Dan Hansen and I'm a Technical Marketing Manager with Cisco's Data Center Product Group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or UCS for short. This video goes over the advantages of the Unified Fabric, which is a foundation of the system. We'll start off with a brief drawing here just showing the Fabric Interconnect pair, which is foundational to the UCS infrastructure, where the brains of the system reside. We're showing some options here for connectivity of chassis to the Fabric interconnects, and we wire it just up front for only bandwidth needs, not necessarily connectivity needs, as those are centrally driven out of the data model, which is the UCS service profile. This all integrates as a single system into the customer data center, and it gets away from having to make definitions on a bay by bay or mez by mez model for attaching servers. We do this through the FEX architecture, which is basically similar to running a conduit, and we administratively define or software define the edge networking, edge storage, and data needs on a per server basis. So we're effectively, again, just running the conduits. We can virtualize all of the switch ports, Ethernet, fiber channel wires. We have multiple data types, can set the data properties in here, fewer adapters, upfront cable, and it makes the programmatic nature of this very straightforward. Now what we can do here also is, instead of terminating on a FEX and running an RJ45 with CAT cable into adapters, eventually as a PCI bus, we have a VIC adapter which we can actually terminate PCI devices direct off of these FEX links. We can do up to 256 of these depending on the model, and we have a full configuration state from the perspective of the OS and the actual server that's being used. So we'll run through some of the advantages of doing this. First off, we'll start off with the UI, that is our interface into the UCS manager. And we'll start with all of this unified fabric and convergence. We'll take a look at how do we apply a QoS, or quality of service class. So globally, we have the ability to enable or disable different levels of service. We can assign a class of service identifier to each of these priorities. And we can turn on or off packet drop behavior and assign a weight metric that goes into coming up with a calculation based on the enabled classes for how much a individual class should get should it encounter congestion anywhere on the fabric. Okay, so we're making this a global definition. We also can assign maximum transmission unit sizes and whether or not it's multicast optimized, i.e. Collapse multiple packets onto fewer frames. All of these are user configurable options. Now, there's also the concept of QoS policies, which can be applied various points within the infrastructure, and these are more granular policies meant to be put on adapters and other devices. So here's an example where we assign a best effort policy, give it a burst value, a rate value, in this case 4 gig, and whether or not we should honor host attempts to mark this COS, or whether we impose it. So we'll show where this is applied. We'll go into a service profile for a 2012 server, and in this particular profile we have 6 Ethernet adapters that are to be assigned to this server and 2 storage adapters. And you see the various properties under each of these Ethernet adapters, where we have some that have what we call fabric failover, and we've assigned a speed to those through our QoS policy, and some that are individual on one fabric or another. And on some we're putting native single VLANs, on some we're trunking multiples with larger MTUs in this case. Now the advantage here again is that not only do we cap or put an on-ramp limit that the server can send traffic into the fabric at, we can also have a ability to allow the server to send at whatever speed it needs to, maximum that the line rate can support, and have the QoS guarantee a bandwidth through the infrastructure also. So another way of looking at quality of service, meter the on-ramps and provide multiple HOV lanes. So we'll jump onto this server that we've just shown there, and we'll be running both a simple freeware iPerf tool, JPerf GUI interface. But first, let's show the network interfaces. You'll see the 4 gig that we assigned is now pushed from the UCS system into the OS. When we assign line rate, it shows the 40 gig that we have going from a given fabric on a line rate interface. Here's another interface that we've assigned a static policy with just 4 gig. And the last one is another unlimited. So you see the ones, and the 2 and the 4 we'll talk about later. Those are undefined or unused as of this point of the recording videos. So if we jump into PowerShell and take a look at the interfaces, you can see the MTUs here are already set to 9,000 for 2 of these jumbo frame networks. So these were actually pushed from the UCS system onto the OS so that we didn't have to, as administrators, go either manually right-click on a properties of an adapter to set its MTU, or do this type of a command that I'm showing here, which is to set the MTU with PowerShell. Now, again, there are tools to do it, to script all this, if we choose to do it that route. But again, we're having more tools that are managed with some external system, and the care and feeding of those devices. We're saying just push it up from the hardware. So we'll start off with an example here showing this JPerf, which is just a simple tool, and we'll be running a test flow from one server to another, and you'll see on here we're getting just under 4 gig on this, minus a little bit overhead. So when we jump back in through our to our box that's controlling this policy, let's set it down to 2 gig now. Save that. You'll see on here, and another advantage is we don't have to go and reboot the server to get this effect. We simply restart the test tool set, and you'll see now we're just under 2 gig that we have set. Now again, this is when we choose to cap or meter the on-ramps of the traffic onto the fabric. If we didn't do this, that bandwidth would show near 10 gig for multiple threads, and it would be dependent on how saturated the fabric is. Just to give an example here, let's go into Windows 2012 and show how we would set up a team and trunking if we did not have these type of capability. We start by taking a look. Here's that Ethernet 2 and 4 interfaces where we're actually sending a group of VLANs from both A and B fabrics to the server. So here I can go into Windows and I can create a team. I don't need an external driver from the adapter vendor anymore with 2012. And I can set these both up, turn these on, and the team is created. If I wanted to do this, I would load, for example, in Linux, I could use the bonding driver and load the kernel bonding driver and do the configuration steps. So on here, when I take a look at the teaming properties, you take a look, you set the load balancing modes, whether it's active or not, how this is actually being used. Now the next thing we can do is go inside of this trunk that we've defined as a team, and now I can take a look at the VLANs. Okay, so I can add interfaces to the system, and I'll do this as an example. I can say, well, I want to peel off VLAN 6 from that trunk and present it to the OS, VLAN 6. I'll do that for multiple VLANs here. But the key idea is, in order to get around perhaps limits in the numbers of adapters that you can put into a server, the physical number of devices, and reduce the number of cables and switch ports, all that need to be added to an infrastructure, what we're saying is through this unified fabric, we can add these administratively from a central point and push these down onto the hardware to add these numbers of adapters, and whether it's storage or Ethernet, on an as-needed basis. So on here, we show an example. If I go into the network connections, you'll see the 2 trunks that or the 2 VLANs that I've just added. At the end of the day, they create an interface on the networks. Now here, I've just jumped ahead to show multiple VLANs that I've defined on the system, and you'll see they all present interfaces in the network connections dialog. What we're saying is, since our virtualized adapters can support up to 256 adapters to an OS, we don't need to go and configure all of those steps on an OS to do more numbers of networks tying into your servers. So on here we can go into something called the VIF path, or the virtual interface path, and you can see all of the path that it's going through the UCS system before it's presented to the upstream world when that server is actually up and operational. So all these virtual circuits. Two important numbers here, the 10259 and 258. The thing to know about those is those are not VNICs to the OS. Those are links to and from the individual processors on our adapter cards that report all of these statistics on Ethernet and then also in storage, but also add and remove and enforce security policy on all these adapters that were created on a given server. There'll be more about that in the security section, but there are additional links to and from the individual server. So when we take a look at these, this card again, and this service profile, and go into the adapters. As an example, let's say I want to create a new NIC. Now this would be logically similar to on a server in our data center, if perhaps not popping the lid and the riser card and stuffing a new card, but hopefully we have a bare Ethernet port on our server and we want to go plug it in. Well, we've got to consume cables, we've got to consume hopefully available network ports in the data center. And some of that, you know, is not going to be easy to do depending on the infrastructure. So what we're saying here is there's a possibility to define it in our service profile right now. We simply save that, saying, there's a new server that new adapter we want to add to this server, and you'll see there's now pending activities. We need to actually go in, since this is done as a hardware PCI device. We acknowledge the fact that we want to make a change to this server, we apply it, and this server will actually go through a reboot process now. But it'll come up, it'll add a new adapter, and it'll present that now to the OS once it's booted. So this is going through something called just a finite state machine, where all the steps that are going through in the UCS, pardon me, to add the server are being run through. And we'll bring up the KVM just to see that the server comes back online. As this is coming up, we'll look at the OS, start its process. You'll see the Cisco VIC actually logging in for this SAN booted profile. And it sees the storage disk and starts booting the OS. At this point, we can jump back over to the server. Now that it's come up, we'll use a remote desktop to actually jump onto this. So we jump onto the local server, we see what's coming up here, the teaming and the new interfaces that are out there, and you'll see a new interface here that says Ethernet identifying VIC interface number 7. So if I go into the PowerShell again and take a look at the adapters, you'll see the top device here, number 7, has the MAC address of the new adapter I've created. Now this has high availability turned on, and we've already defined the network this is connected to. To recap, managing all of the connectivity in the server infrastructure can be a challenge in many customer environments, and the Unified Fabric really helps by simplifying and making it programmatic. This ends the UCS Advantage video, where we show how unique capabilities in the Cisco UCS can lead to a simplified deployment model with much faster service turnarounds to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you.